Ladies and gentlemen, you are welcome to our today class. And of course, today we are going to look at the concept of acid, bases, and involvers. So, what is an acid? An acid, actually, we have a different version. We have different theories of defining acids. We have Bronsted and Lowry. We have Arrhenius definition of an acid. We have Lewis definition of an acid. But in this of our video, we are going to focus more on Arrhenius definition of an acid. So according to Arrhenius definition of an acid, he defined an acid as a substance that donates or as a substance that produces hydrogen ion in a solution. Like for example, according to him, he stated that an acid is a substance that produces hydrogen ion in a solution. So now as an example, let's say we have H2SO4. This is H2SO4. So when adding this H2SO4 in a solution, it will produce hydrogen ion. So any substances that produce hydrogen ion in a solution, so that describes as, or that substance is considered as an acid. So now in a solution where we have H2SO4, it will produce 2 molecular hydrogen ion plus SO4 minus. And this is an acid. And of course, we have different types of acids. So we define or we classified acid on different bases. We can classify acid based on its origin or based on its sources. So that is where we have organic acid and we have inorganic acid. So when we say organic acid, it means that are acids that are obtained from living organisms. And examples of this organic acid, as I said, they are acids that are obtained from living organisms. So it means that it obtained either from plants or animals, or maybe from microorganisms. So examples of organic acids with neutralization acids. Citric acid is obtained from orange. And we have fatty acids. Fatty acids are obtained from fats, fat and oil. Then we also have tartaric acids. We have so many of them. That is one of the types of the acid based on their origin. We also have types of acid. Another type here is inorganic. So inorganic acid, it means that it obtained from non-living organisms. So example, we have HCl hydrochloric acids, we have H2SO4, we have nitric acids. All these are the examples of inorganic acids. So it means that they are acids that are obtained from non-living organisms. And of course, these are the 2 types of the acid. And of course, we also define acids based on their ionization. That is how they ionize in water. So we have what we call strong acid and we have weak acids. So when you say strong acid, it means that our acids that are completely ionized in water. When you have them and when you add them to water, so they are completely ionized. So all the hydrogen ion in that acid will dissociate to produce the complete hydrogen ion. And examples of these strong acids, we will have H2, SO4, it will be dissociated to completely ionized to generate hydrogen ion. So you see here we have two atoms of hydrogen, so it completely ionized. So any acid that completely ionized in water, so the types of acid is called strong acids. And we have weak acids. So weak acids are those types of acid that partially ionize in water. Like for example, let's take an example of ethanoic acids. So under weak acids, we have something like ethanoic acid C3COOH. This is an example of ethanoic acids. So in the ethanoic acid, when you add ethanoic acid in water, to give us something like CH3COO minus then plus hydrogen ion. So you can see here in this case we have CH3COOH and of course we have C3COOH. So we can see that it is only one hydrogen. There are 4 hydrogen here, but only one hydrogen is ionized. So that is why it is mean that it is partially ionized. So that is what we call it. That is an acid. And then we have a base. What is a base? A base is a substances or are substances that when ionized in water, they produce hydroxide ion or hydroxyl ion. Like for example, if we have something like sodium hydroxide. So when you add this in water, will give us sodium ion plus OH ion. So any substances that when ionized in water it produces hydroxide ion, that is OH ion, it means that that substance is defined as a base. And of course we have classification of acids based on their classification of base based on their origin. We have organic base, we have inorganic base, we also have strong base, and we also have weak base. So we should understand that this is not only restricted only in acid, so it also applies in base. So in base we have also organic base, we have inorganic base. That is based on their origin. We also have strong acids and we also have weak acids. So the weak base and strong base. And that is based on their ionization. So you can have a base where the hydroxyl ion or the base is partially ionized. So that type of base is called weak base. And when the base is completely ionized, then that one is also considered as a strong base. And we have acid based on their sources, or we have base based on their sources, organic base and inorganic base. So now, after this, we are talking about acids and bases. So we have a pH. So the next thing that we are going to look at is pH. So what is a pH? A pH is the negative logarithm of hydrogen ion concentration. pH is the negative logarithm of hydrogen ion pH is a negative logarithm of hydrogen ion concentration. So how do we write the pH using an equation? We have an equation which says pH is equal to minus log of hydrogen ion concentration, and of course here is base 2. So pH is equal to minus log of hydrogen ion concentration. And of course, each and every substance, anything we see on this earth, has its own pH. That is why generally, even in material sciences, we can have basic material, acidic material, and neutral material. Like for example, the water that we are taking. We have basic water, we have alkaline water, we have neutral water. Also in the case of soil, we have basic soil, we have acidic soil, and also have basic and neutral soil. So we should understand that pH is very, very important, and whatever you are doing is very relevant and important to know the pH of that particular material. Like for example, if you are taking any kind of food, or if you are taking any types of food, it is important to know the pH of that particular food that you are taking. Is it acidic? Is it basic food? Because they are important, they are relevant in our health. So pH is very, very important, and we have a pH scale. We have a pH scale. How does that pH scale operate? A pH scale is something like this. Starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is how the pH scale operates. So the pH is having a range. pH generally have a range between 1 to 14. So any substances that have a pH between 1 to 6, any substances that have a pH of 1 to 6, so that material or that substance or that solution is an acidic. It's an acidic. And of course, when a substance has a pH of 7 and above, so that material is an alkaline or basic. It is an alkaline. Alkaline, or we can call it basic. What does that mean here? And of course, any substances that have a pH of 7, so that means that that substance is neutral. Is neutral. So now what I'm trying to say in this case is that when you have 1, 2, 3, 4, 5 to 6, and 6 point something, all are acidic. And one very important thing, the lower the pH, the lower the acidic. Like for example, now I can decide to say, okay, we have, let's say, 3 different substances or 4 different substances, and these substances have a pH of, let's say, 1, 2, 3, 4, or let me say 6. So I can ask which one is the most, is the strongest, or is the most acid, is the most acidic. So the one with a pH of 1 is the most acidic, followed by 2, 3, and 6. So 6 here, the material or the substance with a pH of 6, it means that it is weak acids, or it is less acidic. So the lower the pH, the higher the acidity. So the lower the pH, then the higher the acidity. And inversely, the higher the pH, the higher the basicity, or the higher the alkalinity. So it means that in the case of acid substances, the lower their pH, the lower their acidity, and the higher the pH in the case of alkali, the higher the alkalinity. So it means that in terms of alkalinity, if you have substances with a higher pH, it means that the more acidic, the more basic they are. So the higher the pH, the higher the basicity. And then the lower the pH, the higher the acidity. So in the case of acidity and basicity, it's the inverse relationship. That is, if one increases, then the other one will decrease. But in the case of the alkaline or basic substances, the higher their pH, then the higher their alkalinity. And we have ways of calculating pH. And one very important thing that we should understand, ladies and gentlemen, pH is very, very important and is of pharmaceutical and medical application. Because you need to even ask yourself, why is it that you as a nursing student or as a medical student, why do you need to understand the concept of pH? It's because in our body we have different body fluids. We have blood, we have cerebrospinal fluids, we have our saliva, we have our tears. So each of these substances have their own specific pH. And whenever there is a problem with the pH of each and every molecule, it means that there is a problem. There will be a problem. Like for example, the pH of blood is 7.4. So now, if the pH is now decreased, if the pH of the blood is now decreased, what will happen? So there will be a problem. If the pH decreases, then there will be acidosis. And if the pH increases, then there will be alkalosis. So a decrease in a pH of a particular fluid will lead to metabolic acidosis, while an increase in pH can lead to metabolic alkalosis. So that is why each and every material or each and every things that we have in our body or in any other living organism, they have their own specific pH. And remember, in hemostasis, everything must be maintained within the standard within the standard range. And if it is below, then it will be a problem. And if there is, if they actually increase or decrease in any particular, an increase or decrease in a pH of any particular fluid in our body will lead to a medical conditions. So that is why we need to understanding the concept of pH is very, very important. And even the drugs that we are taking, we need to understand that if we are taking drugs, which substance, what is the pH of that particular substances? Like for example now, let's take example with ulcer. Ulcer is an acidic disease. It's an acidic disease because usually what actually brought the problem of the ulcer, we have actually like two different ways. Either Helicobacter pylori, it is actually the bacteria that binds to the intestinal line of the human. Then when it infected, then there is a likelihood that it will actually come up with an ulcer. So a microorganism can cause ulcer. And another thing is that the acids that we have in our body. We know that in the stomach have a pH of 1-2. In fact, if you check some textbooks, you will see that in the stomach, the pH of the stomach is 1.5. It's 1.5, the pH of the stomach. So now, based on the concept that I just explained, that the lower the pH, the higher the acidity. By looking at the pH of the stomach, it means that the stomach is highly acidic. And what is the importance of this pH? It's because, or why is it that it is highly acidic? It's because in the stomach there is strong acids that are produced by the ferritile cells. And that acid is HCl. And what is the main functions of this HCl in the stomach? is to activate an enzyme's pepsinogen, is to activate an enzyme pepsinogen to pepsin. So pepsin is the active form of the enzyme, so pepsinogen is inactive. So the HCl is what actually activates. So the HCl is what activates the enzyme pepsinogen to pepsin. So once you have this enzyme as pepsin, as an active enzyme as pepsin, so we need to understand that in this case, the pepsin, once it is inactive, because it's an enzyme that act on protein. And of course, if we are not taking enough proteins, of course our body is made up of proteins. So our intestine, our stomach is made up of a protein because we have meat in. So if there is no protein, this enzyme pepsinogen will now start digesting our own body. It will now start digesting our stomach and our intestine. So that is how we come up, because there is that the enzymes will be chopping, breaking, eating our own meats, eating our own protein. So as a result of that, we will come up with an ulcer. So that is why sometimes if you have a patient having ulcer, we give him antacids. And why are we giving him that antacid? Is to neutralize the HCl. Is to neutralize the HCl. And that brings us to the concept of neutralization. So what is neutralization? Neutralization is the reaction between acid and base to produce salt and water. So neutralization is a reaction between acid and base to produce salt and water, or acid and an alkali to produce salt and water. An example of that is like in reaction, let's have something like when we have HCl, we have with sodium hydroxide, then we are going to have sodium chloride plus H2. And cold. This is the acid, this is the base, and this is salt and water. So neutralization reaction is the reaction between acid and base to produce salt and water. So what I want us to understand here is this neutralization reaction is very important. So when you are giving a patient an antacid, it's like you are applying the concept of neutralization. Because that antacid, what it does is trying to neutralize the HCl. So that at least once the HCl is neutralized, then pepsinogen will not be activated to produce pepsin. So once that happens, it means that there will be no production of the pepsin. That will be chopping, or that will be breaking our own proteins in the body, or our own meats, because our meat is a protein. So that is why we need to understand this concept. It's very, very important. So that is why advisably you do advise your patient having ulcer, we start out to be taking acidic food. Because if you are doing that, at the end you are going to be increasing the pathogenesis or the crisis of the ulcer. So that is why in that situation, that is why it's not in every case that will be asking your patients to be taking drugs. That is the importance of nutrition and dietetics. So if someone is having ulcer or any metabolic acidosis, what are you going to do? Just try to identify an alkaline foods and ask the patient to start taking that. And that is in black, for example, what are the examples of an alkaline foods? Like apple is an alkaline. So in that situation, you can ask your patient to start taking the alkaline. So if you ask the patient to start taking alkaline food, then it means that it will be neutralizing the acid, and of course, you are able to cure your patient without asking not to take drugs. Because even taking the drugs is toxic. is toxic. So that's the concept of neutralization. So pH is very, very important and it's very, very relevant in each and every aspect of medicine, life sciences, engineering, and many other areas of specialization. So now the next thing that we are going to look at is the pharmaceutical application of pH. Is this pH have any pharmaceutical application? So we should understand that some of the drugs that we produce or that are produced by the pharmaceutical industry, some of them are weak acidic, some of them are weak base. So generally pH, it affects the solubility of weak or it affects the solubilities of drugs that are either weak acidic or weak base. So some of the drugs are weak acidic, some are weak bases. So the pH affects their solubilities. So that is why when synthesizing or when producing a drug, you need to understand the target site where the drug is going to act. Is it alkaline pH? Is it a basic environment? Like for example, if you look at the pH of the blood, it is actually somehow neutral because it's 7.4. But what of the stomach? It is acidic. So you need to think of the types of drugs that you are going to give the patient. Because at the end, if you actually administer the drugs, that will not actually that is not actually in collaboration with the pH of the stomach, that will be a problem in terms of the solubilities of the drugs. It also affects the stabilities of the drugs as well as the absorption of the drugs by the small intestine. So pH affects that. So that is why pH is very, very important. It is very, very important. Okay? So here we are going to look at the dissociation concern of an acid. Because we are thinking about ionization. Of course, if you take an acid and you add it inside water, it will be dissociated. So if you have an acid, let's say you have some weak acids, HA. So this HA, and dissociates between acids plus a conjugate base. So when you have this dissociate in water, you can get an acid. Of course, this is a free hydrogen ion plus A minus. So this is a conjugate base, and this is an acid. So how are we going to get the dissociation constant? So we apply the law of mass action. We apply the law of mass action, and this law of mass action is going to say Ka, that is the dissociation constant of an acid, is equal to, you now take the concentration of the product and we divide it by the concentration of the acid. We are now going to have the concentration of hydrogen ion and the concentration of iodide ion then divided by the concentration of the reactants. So we have this. This is an expression of dissociation constant of water. So you can decide to say, okay, so let's just add log to both sides of the equation. So if you have log to both sides of the equation, minus log, we add minus log Ka is equal to minus log of hydrogen ion concentration times iodide ion concentration divided by H. So we have this. So when we have this can change to minus log Ka is equal to minus log of hydrogen ion concentration. So remember in basic mathematics or mathematical knowledge, this is a division. So division you can change the mission. How do we change the mission? Or divide by Q is minus. So therefore, at the end we're going to have minus log of A minus divided by A. So therefore, and of course, minus log Ke minus log Ke is something as pKa, and minus log of hydrogen ion concentration is something as pH. So you can now substitute minus log Ka with pKa minus log of hydrogen ion concentration with pH. Therefore, now at the end we are going to have pKa is equal to minus log of hydrogen ion concentration, then is pH, then minus log of conjugate base divided by the acids. So we have this. So you can now rearrange the equation by making pH subject of the formula. Therefore, at the end, if we are making pH formula, we are going to have pH is equal to pKa plus log conjugate base divided by the weak acids. So this stands for conjugate base, and of course this one is our weak acids. So this equation is called Henderson-Hasselbalch equation. The equation is called Henderson-Hasselbalch equation. From this, we can calculate pH. We can even calculate the pKa. We can even calculate the concentration of the conjugate base. And of course, from this, we can change it to a POH. So what is a POH? A POH is a negative logarithm of hydroxyl ion. So when we have the pH for an acid to be minus log of hydrogen ion concentration, if we have this as minus logarithm of hydrogen ion concentration, so you can also have a POH where we have minus log of hydroxyl ion concentration. So from here, we can also calculate POH. So you can calculate POH, and of course, we have a formula that says POH plus pH is equal to 14. So from here, we can calculate the POH by saying POH is equal to pKb. Here is not going to be pKa aside, plus log of, here is going to be conjugate acid, not conjugate base, conjugate acids. Then divided by the weak base. So this equation is called Henderson-Hasselbalch equation. Okay. So ladies and gentlemen, the next thing that we are going to look at is buffer. What is a buffer? What is a buffer? A buffer is a solution that resists changes in pH. So naturally, as we are saying, there is a likelihood that, for example, in a living system, when you take any acidic foods or accidentally acid or base get into your body, so there is a likelihood that the pH of the environment will be distorted. Well, let's say you have a solution, and inside that solution, it is neutral. Maybe you have a pH of 7, and you now add an acid. So when you add an acid, what will happen? Of course, if you add an acid, let's say this is the acid. So after you add an acid, you see you have your acids, and of course, let's think the acid is HCl. Of course, it will be associated with the hydrogen ion plus chlorine ion. So let's say your solution or your solvent is water. So let's say you have water. So what will happen? This hydrogen that is formed, this strong acid that is added, it will now react with this to produce hydroxyl ion. Meaning that you add hydroxyl ion or you add hydrogen ion in the solution. So the concentration of hydrogen ion is increased. And normally water is supposed to be neutral. Because in water we expect that the number of OH group in water, when you have water usually dissociates to produce OH minus plus hydrogen ion. So in a situation where you have so if the concentration of hydroxyl ion, so this is minus, if the concentration of hydroxyl ion is equal to the concentration of hydrogen ion, so it means that that solution is neutral. If the concentration of OH, that is the amount of OH, is exactly the same with the concentration of the hydrogen ion, it means that that solution is neutral. But in a situation where the concentration of OH group is greater than that of the hydrogen ion, it means that that solution is basic. But if the concentration of hydrogen ion is greater than that of the OH, it means that the solution or the substance is acidic. So that is the fear. So the pH of this water is 7.0. So but now you add an acid inside the water. Hydrogen ion will release. So once the hydrogen ion is released, then it will now react with the OH group to produce hydroxyl ion. So therefore it means that the concentration of hydrogen ion is increased. So what will happen? The pH will go down. The pH will decrease. So if the pH is decreased, what happens? It means that the acid has mixed off the solution completely. It now changed to acidic, bringing the pH down due to the association of the hydrogen with the water. And of course, it's not in the water alone. In any medium like cerebrospinal, like the brain, all this is what is happening. So that is the situation. So, but when you have a vulva, a vulva is actually a solution that contains both weak acids and it is conjugate base. It is a solution that contains weak acids and conjugate base. Usually contains a weak acid and a conjugate base. So what happened to it? Like we said, in the situation where you add hydrogen ion, the acid, the H, so the hydrogen ion is reacting with water to bring down the pH. And also in the case of OH, that is in the case of a base, when you add base, so the OH group will also be actually react with the water to produce a lot of OH group, and as a result of that, it will change to the basic substances. So now the question is, so someone will ask, so what in the case of vulva system? Is it not reacting with the water? The answer is yes. It's not reacting with the water. What it does is that when you have a vulva system and you add an acid, so instead of the acid to be reacting with the water to produce more of hydrogen ion to break down the pH, so it will now go back and start reacting with the buffer system. And the buffer will neutralize it. And that is why the pH is just slightly changed. So that is how buffer system work. Like for example, in a situation where we have our buffer system, let's say we have our buffer, let's say our buffer is HA, or when it is dissociate, it will produce hydrogen ion plus conjugates. So in a situation where you add an acid, let's say you add an acid, so let's say the acid, so when you add an acid in the solution where there is a buffer system, it will produce hydrogen ion. So what will happen? This hydrogen ion, since we have a buffer system, it will not longer be reacting with another, it will be reacting with the conjugate base. So it will react with the conjugate base to produce weak percentage base, which doesn't affect anything in the solution. And then a situation where you add a base, let's say sodium hydroxide. So it will dissociate, it will use OH minus plus sodium ion. So what will happen in this situation? Then the OH group from the strong acid added, it will now be reacting with this hydrogen so that to generate water molecule, which is not actually affected anything. So this is how buffer system works. In fact, now for example, if you have any disease where, like for example, metabolic acidosis or metabolic alkalosis, what is the best way to cure that disease? You need a buffer system. So some of the drugs that we are taking, they are buffer. They are reference system. Some of the drugs that we are taking, and what they are doing is trying to maintain the status quo of the pH, so that at least it is not going to change. So ladies and gentlemen, this is the concept of acid, base, and buffer. So now the next thing that we are going to look at is how to calculate pH. So let's now look at this example. If the pH concentration of the solution is 4.2 times 10 to the power minus 3, calculate the pH of the solution. So here you are giving concentration of ion, of hydrogen ion, so you are to calculate the pH. So how are we going to do this? So you know that solution. So first, hydrogen ion concentration is giving us 4.2 times 10 raised to the power minus 12. So we have to calculate the pH. So it means that the pH here is unknown. Is unknown. And how are we going to do this? We are going to apply the formula that says pH is equal to minus log of hydrogen ion concentration. So therefore we have the hydrogen ion concentration, so we have minus log of hydrogen ion concentration is 4.2 times 10 to the power minus 7. So this is what we have. So of course remember, according to the indices, according to the law of indices, whenever you have times, to change to positive. So what we are going to do now, we can break this into two. So we can now say pH is equal to minus log of 4.2 plus log of plus log of 10 power minus 3. 10 power minus 3. So now if we have the minus log of 2.2 is going to give us 0.62. And of course this one is minus. So according to the law of the logarithm one, we have log 10. So we have this log 10 power minus 3 base 10. So this one is going to come to this side. So we have log 10 base 10. So any log equals to it is based in the sampling. So therefore, this minus 3 will come to this. We now have 0.0. We now have pH equal to 0.62 minus 3. So what are you going to have? So at the end, from here, we are going to have, if we now press our calculator, then we are now going to have minus, well, already we have minus here. So after we now subtract this from this, then we are now going to have minus open bracket minus 2.3x. So minus times minus is plus, so we are going to have 2.3x, and this is what is going to be our pH. And of course, we know that, as I said, from pH we can calculate. So we know that pH plus pOH equal to 14. So since we have our pH, we can calculate our pOH by saying 2.3x plus pOH is equal to 14. So we have pOH is equal to 14 minus 2.38. So whatever you get is your pOH. So ladies and gentlemen, we are going to stop here, and I'm going to upload all the calculations on the rest. And this actually brings us to the end of water, acid, base, and sulfur.